Welcome to an Arduino tutorial from Robojax. In this tutorial we have a crash course on learning Arduino in 30 minutes with projects. My name is Ahmad Shamshiri, presenting this tutorial from Canada. This tutorial, first we are going to install the Arduino IDE software. Then we are going to learn about Arduino UNO board. Then we run a program to make an LED blink. We learn about if statement, then we learn about for loop, then we will have fading an LED. We have another program reading voltage from potentiometer, and then we learn how to control a servo motor, and then we are going to turn on and off an AC bulb using a relay. And finally, we are going to learn about touch sensor. Make sure to hit the like button and also subscribe so you get updates of my upcoming videos. To write Arduino programs, we need a software called Arduino IDE. We can get it from Arduino website, arduino.cc. Let's come to this website first. Let's go click on software, downloads. This page might be changed, so don't worry and scroll down until you see for your operating system. For Windows, here is the link, and also we have Mac and Linux. Download from one of the links that is relevant to your operating system and install it. For example, if I click, this screen will come. This is asking for donation. Don't worry, click on just download. If you want to make a contribution, click here. After that we can proceed, but let's click here and then save it to where you want. I'm saving it in my downloads, and it says download finished. Now I can click and run, and this screen will pop up. You have to agree, and it asks you for all options. USB driver, select everything, and then click next, and then install. Now it asks for the driver, also install, again install, accept it, and complete it, close. To open it, click on your start menu, type ARD, Arduino, and then open it. So this is a program. When you open the program, this is a function already built in. It's called function setup. This is opening, that's closing. When I click, you see the square, it shows the closing. And also we have another one, it's called loop, opening, closing. Whatever code you put here, it will run only once. Whatever code you put here, it will run continuously. When we work with Arduino, Arduino is referring to microcontroller that is provided as a board, and this is a brand name, Arduino. This is a commercial name, but actually it's a microcontroller which facilitates with USB connectivity, power, and pins. You write your program on Arduino IDE and then download it to this module, and this board later on you can power it up separately without computer, and this will execute the code that you've written. There are so many boards available for programming. This is the most famous one, which I'm going to cover in this course. This is Arduino UNO. We have Arduino Micro, Arduino Leonardo, Arduino 101, Arduino MKR. There are many variations of this. Arduino MKR Wi-Fi 1, Arduino UNO Wi-Fi, Arduino DUI, Arduino Mega, Arduino UNO SMD version, surface mounted device. There are a lot of other Arduino boards, so these were the few that I just shown you. Code that I have written for this course are all compatible with any of these boards. And this is the Arduino UNO board. We have a USB connector. We connect it to your computer. Here is a reset button where when you press it, it will reset and restart. We have a power adapter jack where you can connect up to 25 volts to power this up. We have here a 5 volts pin and then we have a 3.3 volts pin. These pins are labeled G and D. These are ground or negative wire of the 5 volts, and this is also ground. On this side we have digital pins. They have been labeled from 2 to 13, and pin 0 and pin 1 are used for communication. This is RX and TX. And on this side we have analog pins. Analog 0, A0 up to A5. These are 6 pins where you can read analog values. The other pins are for communication purpose. The voltage comes here. It is being converted to 5 volts for this chip and for the USB as well. Power it up with a power adapter from here up to 25 volts will go here, and this is 5 volts supplies for all the circuit. Or you can power it up from this pin VN. You can connect external power from here and the ground. You can connect up to 25 volts, one pin here, the other one to the ground, and it will go here to convert it to 5 volts. These are the digital pins that can be programmed as an input or output. And the pins that have these tilde sign beside them, these are pulse width modulation enabled pin. For example, pin 3, pin 5, pin 6, pin 9, 10 and 11. When we want to read DC voltage, these pins can be used for analog voltage reading. For this project you need a resistor 220 ohm to 1 kilo ohm. You need a LED. You need 2 wires. Here's the wiring diagram for LED blink. I've inserted an LED to the 2 pins of breadboard. This is the anode or longer pin. From this point I've connected a resistor of 1 kilo ohm to another point on the breadboard, where from this point I have a wire connected to pin 2. The other pin, or a shorter pin of LED, have been connected using green wire to the ground. I've connected the resistor here on the breadboard. I'm going to insert the LED. I'm going to insert the longer pin to the resistor side and the shorter pin on the free row. It has been inserted now. One wire here for the shorter pin and connecting it to G and D or ground here, using the other wire to the other side of this resistor, and then connect it to pin 2. Then now let's open a built-in example. Click on File, Examples, go to Basic and open Blink. Setup, we have the word here, it says pin mode and opening and closing, and we have one word and then comma, another one. The first one is the pin number. It says LED built-in. This is a variable constant that is holding the pin number that is referring to pin 13, and this is the type. It says as an output, so you can define a pin to work either as an output or as an input, and that will be run only once. Inside the loop we define what the pin to do. So digital write, using digital write, we mentioned the pin name. This is pin 13 high. This means send 5 volts to pin 13 and then keep it on for 1000 milliseconds or 1 second. This delay means wait. So this is on and waits. And when the LED is off, we show it as a waveform of 0 volt. And for example, after 1 second, if it goes high, that high means it is 5 volts, and then 1 second passes, it goes back to low. So this is the waveform for that LED which turns on and off. And then we say digital write LED pin, this time low. Low mean make it 0 and then wait for 1 second. Then the loop ends and then it goes back and does this thing over and over again, and as a result the LED will turn on and will turn off. Let's upload this and we will see the LED will turn here. Don't worry about this LED now. To upload it, we click here and you will see a progress bar, and then code is completed, and as you can see the LED is now blinking. To change the time and make it blink faster, let's say 300 turn on and then 300 for turn off, and upload it. Now you will see that the code will blink faster. If I connect this wire to pin 13 you will see this LED also will blink together with that. If you want to change it to pin 2, put it to pin 2, and then let's change this to 2, and this one to 2, and to 2, and upload it. Now this will stop, and this LED will blink only because it is connected to pin 2. Now first, let's see how we can define a variable. A variable is a piece of data that you can store in memory, and they have types. For example, I have defined here a variable called age of type integer, and I have assigned 25 to this age. If you have a number with a decimal point, we can define it as a double or float, and this is, let's say, I call it price. And also you can define a character, any character that is on the keyboard, with a single quotation with a type char, C-H-A-R, and this is the name. You can put any name as long as it is not reserved. For example, you cannot put void, you cannot put setup, but any other name that you have, you can put. I'm using now serial monitor. In order to use the serial monitor, to initialize serial monitor to print the text for us, we see serial.begin 9600. This is the baud per second. This is the speed of serial monitor, and then this is how you print the text. We type serial.println, and inside double quote we put our text values. I've printed serial.print the text age, and here I printed age as a variable because it doesn't have double quotation. This one has ln, meaning create new line. So this doesn't have new line, so this text will appear beside this. And then we wait for 2 seconds. This is a 2000 millisecond delay, or 2 seconds. We type delay and then in millisecond. And after that, after this is printed, for 2 seconds it waits, and then it prints this one, the text price and the value price, which I've defined here. And then again initial, and then the text initial, and then the character initial for 2 seconds, and it prints this dash, so we know it's ending. And then because it is loop, it goes and does it again. I've uploaded the code. You can open the serial monitor by clicking at tools and then serial monitor, or we can press the shortcut Ctrl+Shift+M, or on the right side we can click on this icon. Once you click it, it opens and it displays the value, as you can see. But if on the right side, this is the speed, if I select a wrong value, you will see that you will not be able to read it, and you will see this type of character. So make sure that this matches the value that you have set inside your code. So it printed this 25, and then it prints this line, and then it prints the initial, and after that it repeats it again, 25, 3.5, and A. So these are the values that are from here. And here, when you do the if statement, you type F and then opening and closing parenthesis. Inside that you will put the condition, and then this is the beginning and end of action statement. So if this is true, this action will take place. For example, you can check a variable. Let's say if you have a variable called age, and you can check it to be if it is greater than 50. If this is true, if age is greater than 50, let's say 51, then this action will take place. You can have else, which means if this is not true, the action that we have here will take place. We can also have multiple else here. Else if this is not true, then this action. Else if this is not true, if this is not true and this is not true, this will take place. And here age is 45, and then if you want to compare between the two values, let's say if age is greater than 40, these two ampersand symbol means and. If age is greater than 40 and age is smaller than 55, which it means between 40 and 55. If this is true, then the action will happen in here. We can have, or we can use these two vertical line. These are called pipe. So for example, if this is true or this is true, one of them is true, this whole statement is true, and the action will happen, for example, if age is equal 40 or if age is equal 55 or greater. Then if any of these are true, then the whole statement is true and this action will take place. Let's have a look at the if statement. We have defined one variable called age with a value 15, another variable called days. It has 365. Serial monitor have been initialized, and here we say if age is equal or greater than 18, print this: you are an adult and you have left age times days. Whatever age we have times days times 365 will give you the value, and then it press this text. If I put here 20 and upload it, it says you are an adult because it has been printed by this text. You've lived this many and days, so this means take the age multiplied by 365, that's the number. If age is smaller than 18 and bigger than 12, which means between 13 to 17, because 12 is not included. If I run it, it will print some value here, not 45, so it will print this: you are not 45, because age is 12. If it is, this means not equal to 45, then do this. Now if it is 45, now I change it to 45. If I run the code, this will be executed. I just put an example. You can put any other text you want. You can have multiple statements. For example, you can have if, and then you can have else if, some condition and do something. This is the action between these two, and then else. But you can have else if as many as you want. If you want to learn Arduino, I have a bestseller course on Udemy where you can learn Arduino from ground up with hundreds of projects, all course material, library, codes, wiring diagram, everything available in one place. The link for my Arduino course is below this video in the description. When you need to print or do something in a sequence or certain order, we use for loop. For example, if you want to have a value of integer I to have from 0 to 10, we do it like this. We start for loop. This is the opening, that's the closing of the condition, and these are the execution point where whatever you do, it will be executed here. So we have initialization, we initialize I, and we are doing comparison and incrementing. I is equal 0, then we check if I is smaller than 10, which is true, then we print I, it comes back, increment it, so I will be 1, again compare it with 10, I is smaller than 10, again this will print 1, it becomes 2, compare, print, until it becomes 11. When it is 11, compare it, I is not smaller than 10, and it will exit. So now let me upload the code and open it. And as you can see, this is printed 1, 2, 3 up to 10. This using this loop, this I prints 0, 1, 2, 3 up to 10. If you want to start from, let's say, 37 and you want to go to 50, you can do so. And here it started from 35 and it goes to 50. Here we say start with 5. If I is bigger than 0, which is true, then print and then subtract. This is decrementing it, and it goes before 0. It prints 5, 4, 3, 2, 1. Let me open it. 5, 4, 3, 2, 1. From 15, let's say, to 8, it will do so very easily in reverse order, 15 up to 8. Now you can also do, let's say, multiply by 3. So whatever, all these values will be multiplied by 3. Here are the values. We're going to do the fading of this, which means we change the intensity of light of this LED, dim it and brighten it. Let's go to File, Examples, Basic, and Fade. Now this is the LED. It says to pin 9. I'm just changing it from pin 2 to pin 9. The pin that we are using are those pins that have this tilde. The tilde means it's pulse width modulation. For example, pin 3, 5, 6, 9, 10 and 11 are pulse width modulation, where we can fade it. If you connect it to other pins, this will not fade. This line we have defined the LED pin, we call it LED, and then 9 as an integer, and then this is, so we are setting the brightness. This variable is holding the brightness as it changes. This is a fade amount, a step every time with a step of 5. And then inside the setup, using pin mode, we define the LED pin as an output. This is as if I type here 9. And inside the loop, we use analog write and then LED, which is pin 9, and we set the brightness. The brightness is initially 5. And then we get the brightness and then the fade amount. So brightness is equal initially 0, 0 plus 5. This will be 5 and will be here. And then this function, here we say if the brightness is smaller or equal 0, and this means or. If this condition is true, or this condition, if the brightness is above 255, then we put minus fade, so we are changing the direction. If it goes less than 0, we go back to the positive, so we increase it. And if this goes above 255, we go backward towards 0. And then we wait 30 milliseconds, and the loop continuously will increase and decrease the brightness of LED. The code is uploaded, and as you can see, it is fading. You can change this value to go faster, or you can change this time here to make it faster or slower. Now we are going to learn how we can use this potentiometer or variable resistor and then read the voltage from the middle pin of this. Here is the wiring diagram for the potentiometer. The left pin of potentiometer is connected to the ground. The middle pin is connected to analog 0. The right pin is connected to 5 volts. On the right side, this side, I'm going to connect it to 5 volts. We have here 5 volts. And then the middle pin, I'm connecting it to A0. Now this is connected. Now this is a function that I have written. We can read the analog 0. So we have defined it as an integer analog pin. This is just analog N pin. And when you put const, it makes it constant and changeable, so it cannot be changed. And here is the sensor value that from here we will read. It will be a value between 0 to 1023, but we want to read it as a voltage. So here I have created another variable called float. This is a type where it has decimal point. When you have a whole number, you use integer. Inside the setup, we define the serial monitor like this. We'll create a text with a new line, this LN mean new line. Inside the loop, we use analog read. This is reading the pin that you put here, because here we defined it as analog 0. We can put analog 0, but I've used that variable. So this is reading the value and is storing it here. And now we have to convert it to voltage, because the input is 5 volts and the total number of steps is 1023. So we divide 5 to 1023, and this will be a fraction multiplied by this sensor value. So this is multiplication sign, and the result of this calculation is stored in a variable called voltage. And now we are printing it on the screen. We use serial.print, and then if you want to print a variable like sensor value, we type it here like that. Whatever is the value, you will read it. And then this \t means a tab, so between this value and this text, which is quotation, you will create a tab space, So they look in a line, and then this text equal, and then after this voltage we are reading this voltage, the calculated value, and then we have 50 millisecond delay. The loop will continuously take the same action. Now let me open the serial monitor, and this is now we are reading the voltage. Now this is my potentiometer, and currently the potentiometer is almost to the left, and as you can see we are reading 27, and it corresponds to 0.13 volt. If I rotate it to the maximum quickly, you will see that it shows 1023, which is the maximum value for this, and that is the voltage that we are reading. It shows 5 volts, and if I put it somewhere in between, you will see that we are reading 2.68 volts, and here at the middle almost 2 volts. So this will give you the value of the voltage from the middle pin. So this way you can read the voltage. This is a servo motor that can be controlled to go between 0 and 180 degrees. It has 3 wires. Brown will be connected to ground, the middle one is connected to 5 volts, the last pin or lighter color goes to the signal where it receives signal to be controlled. Here is a wiring diagram for the servo motor. The brown or darker wire is connected to the ground, the middle wire is connected to 5 volts, the orange wire, which is the input signal for the servo, is connected to pin 3. Here I have connected the red to 5 volts, the brown to ground, and then the orange to pin 3. On Arduino, click on File, Example, scroll down until you see servo, and then sweep. This is the code. We can control a servo. This line says the servo should be used. This is a class, and we are creating this my servo, and this we are creating my servo object. The position, this variable is holding the position. This line is attaching servo to pin 9. We are changing it to 3. This loop will change the position from 0 to up to 180, and every time increments it with 1, and then when we send the servo to any position, we say servo.write, and then pause. This pause, which changes between 0 to 180, when we give it 15 milliseconds, so the servo moves up to 180, and then this loop will start from 180. As long as it is above 0, it decrements, subtract from 180, 179, 74 up to 0, and then move the servo to the position, and then we give it 15 milliseconds. So this will go send the servo from 0 to 180, and from 180 back to 0. Now let me upload the code. And here the servo goes between 0 to 180 and comes back. Now we are using a relay to turn on and off an AC bulb or DC bulb. Relay is a module that can create a contact or turn on and off a load. It has 3 pins here. VCC will be connected to 5 volts, GND or ground will be connected to ground of Arduino, and this will be connected to pin 2 where we send the signal to this. This red will turn on when this has 5 volts. The green will turn on when this receives signal. This module will turn on when it receives 0 at input pin and will turn off when it receives 5 volts. Inside we have 3 pins where we will connect our wires for the load. This is called normally open, this is called normally closed, and this is called common. We will connect 2 wires to the common and normally open to turn on and off a light. And here when I power it up, you will see the contact go up and down. This goes up and down to connect and disconnect. You might see a relay of 1 channel. This has 2 relay and it's called 2 channel. You will see 4 channel relay, 8 channel relay, 16 channel relay or higher, 16 channel relay or higher. This is a desktop bulb where you connect it to the wall outlet and the light will be turned on. At the middle, I've disconnected one of the wire, the live wire of this, and I will be connecting it to relay. The job of relay is to connect it to turn on the light and disconnect it to turn it off. Here is the wiring diagram for the relay. From AC, we have two wires. These are the two wires that I just shown you. You will connect one of the wires to this pin, the other wire to this pin, and this is your AC bulb. And on this side, from the left side, it is connected to 5 volts. The middle pin is connected to the ground, and the right pin is the input. It is connected to pin 2. Here is the wiring for the relay. I've connected the left pin, the 5 volts, to 5 volts of Arduino. The middle pin is ground. Using this red wire, I've connected it to the ground. And then the last pin is in. The in is connected to pin 2. And the two wires from AC bulb are connected to these two pins. And here is the demonstration. The relay is turning on. This green light will turn on, and also the bulb is turning on. Also, I have here the text on serial monitor where it shows relay light on or light off. I've changed the time to 300 milliseconds for turn on and 500 for turn off. Let me upload the code. The code is uploaded now, as you can see. It turns on and off very quickly. This is the touch sensor TTP223. It is sold like this, and you might receive it without these header pin soldered, so you have to insert and solder it, and it has simply 3 pins. One is for the VCC, which is 3.3 volts or 5 volts. The other one is ground, and then the middle one is the output from this. When you touch it, the output state changes from 0 to 5 volts, and you can detect it using Arduino to do something. This is Arduino Sketch for Touch. We have defined here a pin called touch pin as type integer. I've assigned pin 2 to this variable. By the setup, we have initialized serial monitor and printed this text. And in this line, using pin mode, we have defined the touch pin, pin 2, as an input, so we can read the touch signal. Inside the loop, we use if condition, and if this is true, then we print this text which says touched. Here is what we do. We use digital read, and we say read touch pin, which is pin 2. This is as if I type here 2, and we check it if it is equal high. When we compare something, we put 2 equal sign. If it is high, then we say serial print touched. When it is touched, we see high here, and then it goes and waits 100 milliseconds, and the loop will continuously does the same thing. If nothing is touched, we will not see anything on the screen. Here is the wiring diagram for the touch sensor. The ground pin is connected to the ground of Arduino. The middle pin, which is the output, have been connected to pin 2 of Arduino, and the VCC, the lower pin, is connected to 5 volts. Let me show you now the wiring. Ground is connected from this side to the ground of Arduino. The last pin on this side is VCC. Orange wire is connected to 5 volts. The middle pin is the output. In out it says the output is connected to pin 2. I'm uploading the code now. You will see the main text waiting. So now the touch is uploaded, and here when I touch, it says touched. Because we're reading it 10 times a second, if I hold my hand longer, it will say touch, touch, touch continuously. And here we can do something. If you want to do turn on a relay or something. Thank you for watching the tutorial from Robojax. If you like this video and learned something, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. create a contact or turn on and off a load. It has 3 pins here. VCC will be connected to 5 volts. N will be connected to the signal. VCC will be connected to 5 volts. GND or ground will be connected to ground of Arduino, and this will be connected to pin 2 where we send the signal to this. This red will turn on when this has